Good afternoon. Welcome to SVS330. Hopefully you're here because you're looking to understand how ECS can help optimize your platform strategy. Or maybe you're already an ECS or an app runner customer and you're looking for some best practices. We are planning to walk through some common patterns that we see customers using today. My name is Jennifer. This is Ollie. We're your ECS experts today. We're also going to be joined later by Michael from Fannie Mae, who's going to be talking to us about how an application team has consumed ECS and their experience. With that, let's get started. So first, I'll start with the word platform team. Maybe you don't call it that within your organization. Maybe it's centralized IT or Cloud Center of Excellence. Just want to baseline that before we get started. Usually you have a platform team because you have many application teams who are working on many applications and using a plethora of AWS services. And it's these combinations and exceptions that really start to create a sprawl within your organization. And then a platform team enters. The conversation that inevitably comes next is, what kind of platform team are we going to be? Do you want to be very decentralized, where you really allow those application teams to operate more in a DevOps model? They can deploy and maintain their own infrastructure. They have ownership over what they've deployed. Or do you want to be more centralized so that teams have less flexibility, but they're able to really focus on creating business value and actually coding? But the reality is that this is more of a spectrum than two realities on either end. So that's really what we want to dive into today, is what is that spectrum and what does it look like, and what are some of the patterns within ECS that we see. To start with that, we're going to use a metaphor. Hopefully, because this is after lunch, this is not too offensive to anyone, but we wanted to use the metaphor of food. So starting on the left, we have a bag of groceries. So this would be like, consuming a bunch of AWS APIs. You give people access to everything. In this world, you go to the grocery store. You have to pick out a recipe. You have to clean and chop and prepare all the food. And you really own that whole process end to end. And you do a lot of things in that process that are not actually eating the food. But maybe you enjoy that and you love knowing where everything came from. The next one is one of those home meal delivery kits. Where there's some things that have been chosen for you, things that have been done for you. You get one egg instead of having to buy a dozen. They deliver you just the right amount of balsamic vinegar or whatever you're using. But you also have flexibility. If you had a homegrown tomato from your garden, you could use that as well. Or if you're allergic to something, you can leave it out. You have shortcuts installed, but you can also have a lot of flexibility to do what's right for you and your dinner. Frozen dinner is next. I apologize, this one is not very appealing. But the idea here is that a lot of the work of preparing is done for you. And you still have choices when it comes to deployment, or when you decide to cook the food. You choose whether you eat at 3 a.m. or lunchtime, and you can choose how long you cook it. You don't have to necessarily follow the instructions, but you have some freedom there. And then the last one is a chef-prepared meal. You might not even know what's in the plate, how it came to be. You sit down at the restaurant, they put a napkin in your lap, it's all done for you. It's a really lovely experience. All you have to do is eat. So we're going to come back to these abstractions a little bit, and just to drive home the point of these different kind of patterns that we see. So what does that look like in terms of voice of your developers? On the left hand, you have your grocery bag. They want to be exposed to all of AWS. They want ownership. They want flexibility. They want to know what's happening. And on the right end, you have kind of the opposite. It's that very centralized model of, here's my source code, can you just get it running, please? But the reality is, we see most of our customers existing somewhere in the middle. And actually, sometimes it's a lot of a mix as opposed to one independent pattern. But these look like, give me a blueprint, usually infrastructure as code, or I want to deploy, but I don't want to know about the infrastructure underneath. So can you give me a model where I can just tell you what I need in order to get my application running? So a little bit about the patterns that we're going to evaluate. We'll come back to those later, but I wanted to touch upon why this session is about ECS and what ECS is. So ECS is Elastic Container Service. It's our opinionated container orchestrator at AWS. You have options in terms of what kinds of compute you can run underneath those containers. So you can use EC2 instances, you can use your own hardware with ECS Anywhere, but the overwhelming majority of our customers choose AWS Fargate. Fargate is a serverless, pay-as-you-go compute engine for containers. Why do people love Fargate? Because we manage the operating system, we manage the patching, we manage the security updates, we manage a lot of the things that you would have to if you were doing your own EC2 instance, but we consider that to be undifferentiated heavy lifting that we would like to relieve you from. A couple of stats updated for ECS. We launch over 2.4 billion tasks every week. Over 65% of new containers customers at AWS choose ECS, and the overwhelming majority of those are choosing Fargate. Incidentally, we also consider ECS to be a foundational service at AWS, which means that anytime we stand up a region, we always put ECS in as one of the very first services because so many other services depend upon us and build on top of us. So ECS is an excellent choice as a container platform, but why is it a great choice for platform teams? And the reason is we really consider that building on ECS is building on AWS. That seems very straightforward, but what we mean by that is that we really focus on deep integrations with other AWS services. And so we want to make sure that anytime there's an AWS service that really makes sense for containerized applications to be taking advantage of, we make it simple for customers to take advantage of those benefits. And we work with those teams and make sure that it's kind of a venue for using the rest of AWS. So I'd like to take a minute to just walk through some of those integrations so you get an idea of like what those deep integrations look like. First, we'll talk about infrastructure. A very important aspect of ECS is that there is no control plane to manage. There's nothing to maintain, nothing to upgrade, nothing to patch. We handle it. We run the control plane on your behalf. And if you choose AWS Fargate, we also manage the patching and the scaling of your data plane. We have native service discovery built in with Cloud Map, AWS Cloud Map, and then we also have tenant isolation with AWS Fargate. So this is kind of a nice built-in security feature where you're getting the benefit of the EC2 instance boundary from using Fargate. Every task would get an independent EC2 instance, even if it's within the same ECS service. So thinking about security for a second, we'll kind of double down there and talk about some of the security integrations we have. We primarily use IAM as our mechanism for restrictions and permissions, as do most AWS services. But we really have considered the resources that we make available within ECS and make sure that those make sense in terms of whether a platform team would want to restrict or allow permissions to those resources. We also last year at re:Invent announced integration with GuardDuty. So this is runtime threat protection that you can turn on in ECS at the account or cluster level. And just earlier this year, we announced integration with VPC Flowlog. So that means for your Flowlog subscription, you can add data about the ECS cluster, service, or task so that you can know who is making those calls from within your ECS services. A couple more integrations. Sometimes ECS services is not the right way to launch tasks for your workload. And so we also integrate with step functions so you can trigger off of an action and batch so you can launch lots of tasks at once. We've also always had very deep integration with the Elastic Load Balancer. You can create target groups from within our console. We consider the ELB health checks as a part of our scheduling decisions. So that means that if you fail a health check in your application load balancer, we will consider that task unhealthy and replace it. We also just a week or so ago announced integration with VPC Lattice. So we will also consider those health checks going forward. And just yesterday, we announced enhanced Container Insights. Container Insights has been very popular with our customers. When you turn it on at the cluster level, you get automated dashboards and CloudWatch and metrics about your services and clusters. And now with the enhanced option, you can also get metrics about your tasks and containers. So coming back to our spectrum of developer needs and the options that you might want to evaluate there. And let's put some names to them. So starting on the left, I'll cover account as a service. This is a very straightforward one, so we'll use that to kind of set up the framework. These are also, I'll say, names that maybe you've seen used for other things. They're kind of overloaded, but the goal of this is to give them a name so that you can think about them in the context of ECS and whether it would be a good fit for your organization or not. So account as a service. What is account as a service? For platform teams, this means that you're creating a landing zone. We have lots of documentation at AWS about what it means to be a landing zone and what kind of security controls and IAM policies and limits you can put in place at the account level before you vend those over to a developer. You can use AWS Control Tower to do that. But we also have within ECS some account level settings. So you can set up tagging and container insights and guard duty and these kinds of integrations that we built at the account level so that you can make sure that every ECS service launched in that account is using those things. For the application teams, this means that they have full development responsibility as well as operation responsibility, and they have access to what other APIs that you've allowed them access to. So now for each of these patterns, we're going to go through the good and the bad. So on the green rainbow side, we have that developers have full autonomy, and really it supports a very wide range of workload types. So ECS is really great at doing load balanced web applications, but if you don't put any kind of restrictions in place, it can also do event-driven or a Gen AI workload or something driven from a queue or a background worker. All kinds of workloads can be run, and if you don't put, it kind of follows that tenet of abstraction, where if you add more abstraction in, you get less and less flexibility. And so this is kind of the lowest level of abstraction and the most amount of flexibility. You also get full isolation between teams and workloads. You already get that a little bit with the isolation boundary, what we talked about in Fargate, but at the account level, that gives another isolation level. The other benefit there is that it makes it very easy to attribute costs to a certain team or workload. Some things to consider, though, is that there's really no standardization in this model. So it makes it really difficult to find patterns. And application teams are taking on that cognitive load, especially when it comes to troubleshooting. So that's account as a service. Really good fit for some customers and some workloads, especially if your developers are very engaged. But I'm going to hand it over to Ollie to talk about the opposite end of the spectrum.
Okay, thank you. So yes, so we've gone from one end to the other. We're now going to take a look at platform as a service and see how that pattern fits in with Amazon ECS. Going back to Jennifer's metaphor at the beginning, she said platform as a service is almost like going to a restaurant and going out for dinner. You as a developer, you're not having to prepare anything. You're just picking what you want from a menu, and it's being served and presented in front of you. And comparing that to developing applications, you're turning up with your source code, and you don't really care where it's running or how it's architected. So there's lots of definitions for platform as a service, and it's not a new term. But just to kind of level set in relation to this presentation, The application teams, they just focus on building their applications. They focus on writing the business logic and working on their code. They have limited knowledge of where the application is going to end up. They don't know it's running on the cloud. They may not know it's running in containers. They may not know it's running in ECS, but they're just happy working on their business logic. Then the platform teams in this case, they're there to build and operate the platform. And it's their job to then expose a limited number of workload types, i.e. the menu, to those developers. So what could this look like on ECS? And to be clear, I'm not saying ECS is a platform as a service. There are additional components that you need to build a PaaS. But earlier, Jennifer called out some of the key benefits of ECS. And they fit really nicely if you wanted to build a PaaS around it. Because not only the control plane is managed for you, there's little overhead for the platform team there. Same thing for the data plane. And the fact that there's that single tenancy model, especially with AWS Fargate, that if multiple application teams were consuming the same PaaS, you wouldn't have to worry about the security boundary because AWS Fargate isolates each workload. That being said, to turn ECS into a PaaS, the platform team would have to get building. They would probably build a sort of an in-house API layer or console or something like that to provide a front door for their development teams, as well as piecing together the rest of the stack. They build a CI/CD pipeline, some observability, maybe pair it with some additional AWS services depending on those workload types, like a database service. Now, if you wanted to go down this model but didn't want to go about building the platform, you could take a look at AWS App Runner. So AWS App Runner is built on top of ECS, and it adds in some of those components that you need to build a PaaS into the managed service. Developers can still focus on building their applications and writing their business logic, but now more of the burden of actually operating the PaaS gets passed over to AWS. Now, AWS App Runner is a great service if the workload type is for APIs or web-based workloads. And AWS App Runner takes on some of that undifferentiated heavy lifting of running the platform. So App Runner takes on the idea of building container images if you wanted to remove that from the developer. It comes in with an integrated level 7 load balancer. It has integrated auto-scaling that's based on the number of requests that load balancer gets. It has a built-in pipeline. It has built-in observability. So if you wanted to go down that platform as a service route, maybe just for one workload type, take a look at AWS App Runner and see how it's able to remove some of the undifferentiated heavy lifting of operating the PaaS onto AWS. So is PaaS right for me? How does platform as a service tally up in the scorecard? Well, on the good news, developers can deploy quickly. They can just focus on their business logic, maybe just focus on packaging up their application as a container image, and everything else is taken care of for them. It's reduced that cognitive load. They're not there having to learn about infrastructure. They're not there having to learn about AWS services. You get a nice set of standardized workload types and patterns. All of your applications will be deployed exactly the same way on the same set of tools. And from an organizational level, you have standardization. And then with AWS App Runner, you're actually able to pass off a lot of the burden as part of the platform over to AWS. On the con side, platforms as a service are normally quite scoped down to a subset of workload types. Now, that's great if your workload type fits, but if the developer turns up with a new machine learning or training workload, it actually becomes quite a large overhead to support additional workload types, and it may be quite restrictive in that manner. So if you go down this model, you may need escape hatches or a way for you to deploy other workloads. And then finally, building and operating the PaaS may become a burden, especially if you have lots and lots of application teams onboarding, then you may need to scale your platform team accordingly. Okay, handing back over to Jennifer to talk about cluster.
Sounds good. So like we said at the beginning, we see fewer customers at the extremes, and most people are kind of in the middle on the spectrum somewhere, kind of consuming some set of these patterns. So for cluster as a service, what are we talking about here? Maybe I'll talk for a second just about, because we haven't yet, I'll baseline what the resources are in ECS. We have the cluster, which is kind of just a logical grouping. It also defines what kind of compute you're going to use. We have the service that really describes your application networking, how you're going to deploy. It's kind of the heart of your application. And then we have tasks and task definitions, and that's really the description of your container. And the value of having these as distinct resources is that you can kind of split that responsibility. So when we say cluster as a service, we're really talking about a platform team creating a cluster, vending it to your developers and saying, here, please use this cluster, these VPCs, this load balancer, whatever you've created on their behalf, and they can cobble those together into the application using the service and task definition constructs. So in this model, application teams absolutely know that they're deploying in ECS, and they're able to troubleshoot because they have access to the service and to the task definitions and the metrics that come along with that. And they also are learning how to debug at a very deep level. On the platform team side, you're creating these clusters, and you're sharing them or creating independent ones for every team or workload that you're creating. You also have the option of putting things like a governed pipeline in front of it. So visually, here's the distinction between platform team and developer. But what I wanted to kind of highlight is that on the right side there's still a very kind of shared responsibility model here. There's things that you need to consider, that you may need to do some things, and the developer may need to consume them. L7 load balancing, for instance, a lot of teams don't want their developers creating their own security groups for the load balancer. And so they'll create that load balancer, give the ARN to the developers, and they'll insert that into the service so that they can use that particular load balancer. For the CI/CD pipeline, you may set that up, and they may have to consume it and push their code to that pipeline. For security, you could turn on guard duty at the top level, but maybe they are responsible for setting it as a public or a private service. Observability, you can turn on container insights at the top level, but they may need to configure log groups within their task definition. So there's some things on both sides. So here's the thing about ECS clusters. Because there's no control plane to manage, the overhead of creating a lot of different clusters is very minimal. So if you have 100 teams and you need to create 100 different clusters, like, you can do that. You can go wild. You can be like Oprah, distributing clusters left and right. But you may have some microservices that are sharing some kind of boundary, sharing the namespace, and they need to talk to each other, and so you can also share those very easily. But I think that's a huge benefit of ECS, is that the simplicity of creating those boundaries as you see fit and what makes sense from a logical standpoint is very easy. Is cluster as a service right for me? Developers have a lot of autonomy in this model because they do have full control over the service and the task definition, but they have a reduced cognitive load because they're not thinking about all these other infrastructure services that you are creating and vending to them. You can still use most workloads and workload types, and you have that built-in tenant isolation from the cluster level as well as from the EC2 instance boundary from Fargate. On the other side, you do have developers that are having to learn about what is a task definition. And so there are some things that they're needing to understand, how to create a target group for the load balancer and integrate that into their service. There is a little bit of cognitive load here, but it's reduced in scope. And with that, I'll hand it back over to Ollie to cover the next one.
Thank you. So the final one of our four is template as a service. Back to our metaphor again, this was the meal kits. This is the idea now where developers have some level of prescription. They're being told what they're going to be making, but the idea of actually making it and cooking it and operating it falls on them. So what is template as a service? We'll start on the platform team side. And this is where platform teams are packaging in all of their best practices and all of the, I guess, architectural patterns and designs into infrastructure as code templates. So it's now a bit of a distributed model. The platform teams are the ones that are going out there doing research on the best ways to run a certain workload type or a certain AWS service, and then packaging that up into an infrastructure as code template. And then they're iterating on this template as new best practices or new features or new options become available. And then application teams are then consuming these templates. And then the application teams pick what they want, they deploy it, and then they operate it. So how do you define a template for Amazon ECS? Or maybe even what is in the template for Amazon ECS? Now, when I speak to different customers, organizations do this slightly differently depending on what they want to expose to their developers and how much autonomy they want to give them. And there is even more abstractions in these templates. At the very bottom, some organizations like to expose foundational components to their application teams. These are explicit AWS resources, so maybe an ECS service or a VPC subnet or maybe a security group. And so a platform team might write a CloudFormation template, which is the best practice VPC with all of the correct security groups, all of the correct routing rules, NAT gateways, et cetera, and pass that then over to the application teams to consume. So every time an application team needs a new VPC in a new environment, they can consume that blessed template from the platform team. You could also do very similar things with CDK or Terraform. The next level up is when we start to see platform teams have opinions on how workloads should be deployed and actually start to abstract those foundational components away. So they start to create modules or templates at a higher level. They're now maybe workload specific. So consume this module if you're deploying a load balanced web service, or consume this module if you're on a queue consumer-based service. And the platform teams have gone through and done all of the underlying legwork of putting together these foundational components into this higher level template. AWS has provided a set of layer 2 CDK modules for ECS that does this for you as well. So some of those workload types, like web-based services or queue consumer services, are available as CDK modules, or you can take advantage of Terraform and build modules yourself that are workload specific. And then the final option we see, and this is really when organizations want to kind of go very abstracted away, and they kind of create their own workload definition standard or own workload spec. And they tell their application teams, okay, if you're deploying a web-based service, write a JSON file or a YAML file with 3, 4, 5 parameters in there, and then we'll take that and populate it into one of our modules in the pipeline at deployment time. And we're seeing more and more organizations go down this path of actually providing a module or a template, but abstracting a lot of it away and really kind of reducing the cognitive load on developers through this templating model. The question then becomes, regardless of what templates you choose, how do you then distribute those to your application teams? Now, there's lots of different ways to do this, but one of the popular ways to do it at the moment is going down the route of an internal developer platform, or an IDP. And I've taken here a definition from internaldeveloperplatform.org that an internal developer platform is built by a platform team to build golden paths and enable developers to self-serve. And so what you're doing is you're distributing templates through IDPs to your application teams. Now, there's lots of different IDP tooling out there, but they have a lot of things in common. One of the first things they have is they should have role-based access control. Application teams are limited to maybe what templates they can choose, but definitely to the resources that have been provisioned through the IDP. So each application team only gets access to their their resources. These IDPs should be self-serve. The application teams can just log on or hit an API and start consuming templates and looking at resources. They shouldn't have to go through the platform teams every time they want to deploy new resources. There should be a level of configurability, taking those templates, customizing them for that workload. Maybe it's through that workload spec or workload definition that you've developed in-house, where the application team is putting in a service name, a container image, an environment variable, whatever it may be. There should be integration from your IDPs into the deployment pipelines as well, so that inside of one place from the IDP, you can visualize an in-progress deployment, you can see the statuses of previous ones, and there should also be a level of orchestration. These IDPs should be triggering off automation, they should be deploying things in your environments. Now, there's lots of IDP tooling out there, but a popular one that's gaining momentum at the moment is Backstage.io. Now, Backstage is an incubating CNCF project. It was originally created in-house in Spotify that they then open sourced and gave to the CNCF, and now it's flourishing inside of that community. And Backstage is an open source framework for building these developer portals. Backstage is a very pluggable and has a pluggable architecture. It has a number of core modules, so modules like the software catalog, where you can discover provisioned resources, software templates, where you can see the templates shared by the platform teams. It has built-in documentation, built-in search, but then it can also be customized. There's a whole ecosystem out there of plugins that you can use to create the perfect IDP for your organization. So it would make sense to go and integrate into your source control and into your CI/CD pipeline, into your infrastructure, as well as into your AWS services. And there's a number of AWS services out there for Backstage, including into code pipeline and code build, so you can see the status of your CI/CD. There's a plugin there for Amazon ECS. So as application teams consume templates and provision resources, they can see what those resources look like inside of ECS, and they can check on their status. Here's a screenshot of that ECS plugin. So inside of Backstage, you can see your provisioned resources in the software catalog, and if those resources are provisioned on ECS using tags, you can then populate Backstage with your provisioned resources. And then if you want to go out and get started with Backstage, it can be a little bit intimidating at first. So a team inside of AWS has created a project called Harmonics, or Harmonics on AWS. And Harmonics on AWS is a reference implementation of Backstage on AWS. So they provide the getting started, a reference implementation of deploying Backstage on AWS, as well as pre-installing a number of those community plugins so you can see your AWS resources inside of Harmonics. They've gone through the trouble of creating a reference implementation for creating environments and vending environments for different application teams. And they've also created a number of templates for various workload types on Amazon ECS and our other serverless services. Okay, so is template as a service right for me? Well, going back to our scorecard, developers can still get started quickly. That was one of the names of the games, regardless of what abstraction we chose. We didn't want to slow down developers. So they can still get started quickly. They can just choose the templates from their IDP and get deploying. Platform teams can now scale in this model. Because the platform teams are not the ones owning and operating the infrastructure, just vending the templates, you can actually have quite small platform teams scaling and supporting a large number of application teams. And you're still enforcing standardization. Through putting all of your best practices into infrastructure as code, you're still implementing standardization inside of your organization, but there are escape hatches, right? You can create things outside of the templates. You can customize the templates depending on what the application team wants to do. Some of the cons, the application teams are now exposed to the infrastructure. If you wanted to have that platform as a service-like experience where a developer just gives you your source code and not worry about where it's running, this model isn't that. That being said, there's no reason why you can't start mixing and matching. And as Jen mentioned earlier on, some organizations will pick different models for different application teams. So some may be doing platform as a service for their web and API workloads and template as a service for their other workloads. And in the final con, there is still some dependency on the platform team. They will probably be operating the IDP and maintaining it and implementing new plugins and things like that. So throughout this presentation, we've kind of introduced this abstraction spectrum. We've talked about different ways people are building platforms on ECS. There's definitely no right way, but we hoped we've provided enough of a flavor of different ways that you can do it and popular patterns we're seeing across different customers. Whether that's just vending accounts and landing zones for application teams in account as a service, or whether that's platform teams putting best practices in infrastructure as code templates in template as a service. Maybe platform teams vending vending clusters inside of cluster as a service and taking advantage of the tenancy models in ECS and AWS Fargate to provide each application team and each workload their own cluster. Or finally, platform as a service, where the platform team take on the burden of operating and running the infrastructure, and developers can just focus on their source code and business logic. So at this point, I'm going to hand over to Michael. Michael works for Fannie Mae, and he's going to talk about their journey and how they've built on their abstractions for serverless and serverless compute.
All right. Thank you, Jennifer and Ollie. I am super excited to tell you how and why Fannie Mae transformed loan accounting using ECS, Fargate, and other AWS services. I can't wait to share how we use an IDP powered by AWS for Fannie Mae. Results include everything from accelerating developer onboarding. We saw a massive increase in dev joy, or what we call developer joy. And most importantly, we facilitated self-service for our stakeholders. I am Michael Lee. I support finance, HR, and climate at Fannie Mae. Okay, before I get started, I got to do a quick history lesson. Fannie Mae is situated in Washington, D.C. with 8,100 employees. Fannie Mae was founded by Congress in 1938 with a mission all about homeownership and affordable housing. I got a big numbers alert here. We finance 1 in 4 U.S. mortgages. We manage over 18 million loans, and we hold $4 trillion in assets. Fun fact, we have the largest balance sheet in the United States and the 5th largest in the world. Here's the thing, though. Fannie Mae is not a lender. What we do is boost liquidity by purchasing and guaranteeing loans from lenders and packaging them into mortgage-backed securities. Those then go into the secondary housing mortgage market, which then ultimately supports the housing market with accessibility and affordability and stability. In addition, Fannie Mae drives innovation and positive change in housing from everything from sustainability to affordable housing and rental options. Okay, that was a quick history lesson. You're probably asking, what's the so what? The so what is that for an 86-year-old mission-critical company that is fundamentally a risk management platform, we are built on some truly wondrous and fabulous modern technologies. But to get to those wonderful technologies, an 86-year-old company is bound to have legacy challenges. And I'm going to be talking about one of mine, which is this behemoth loan accounting system that took over 200 plus people to build, took 3+ years for us to put into production, and it ended up with a monster app managing 90% of our massive balance sheet. We're talking enormous scope, 10,000 calculations and 5,000 business rules. In addition, we're always racing against the clock in this monthly marathon for us to process 200 million accounting events. Meanwhile, we're running in outdated cement shoes, which is built on 350,000 lines of Java code, heavily ETL, extract, transform, and load processes dependent, and business roles embedded in non-intuitive silos. Oh, and I didn't mention our integration overload. We interface with 70 other systems with a database footprint of 500 plus tables. So why change, you're probably asking, if it works? Well, Fannie Mae hit a tipping point. Infrastructure and customization challenges led to silos and a poor developer experience. There was very little dev joy on my portfolio. We also had tech turmoil. Our fragmented landscape without consistent design patterns made maintenance a nightmare every month. And most important, we had manual mayhem for my beloved accountants who toiled on laborious processes and strained their overall cognitive load. So, working closely with the business, so business and tech came to a decision. As part of our cloud journey, rather than rehost, we chose to refactor, aiming for long-term benefits of AWS and a custom-built low-code platform. In what I can only describe as cloud-native magic, we built a fully functional system in 1 year with 40 people using AWS services and cost-effective serverless. I'm going to be back on the cost-effective pretty shortly here. Ali talked a bit about template as a service. I will say that ECS template as a service was a triumph for us because it enabled a standardized IDP, allowing system implementation by an empowered development team rather than a dedicated infrastructure team. We also got a turbo boost with our low-code engine because it can now gather requirements, model, validate, and generate Node.js code automatically without any manual development. We slashed lines of code by 22%. We improved system performance by 65%. And now 90% of our code is generated automatically. And best of all, my accountants love this, we saw 33% lower technology costs. So how did we do it? The new accounting system harnesses ECS template as a service design and the power of serverless Fargate containers. This integrated technology stack serves as our IDP with a highly reusable design, which is perfect for ETL, outbound data frameworks, our core engine, and various utilities. Within the IDP, Terraform templates provision ECS and other standard infrastructures, while this AWS Service Catalog ensures that we've got consistency and compliance with our organizational standards. Data storage. So the beauty of ECS is it provides a seamless integration with Aurora PostgreSQL, which is the heart of our accounting engine's transactional database. ECS also integrates with S3 file storage, which manages both our inbound data from our upstream systems and our outbound data to our downstream systems. And then our system is ultimately elevated using AWS and ECS, enabling truly amazing automated orchestration and a robust event-driven architecture. AWS step functions orchestrate the entire process, while Lambda, EventBridge, and SQS foster an event-driven pattern to kickstart our Fargate tasks. And ultimately, CloudWatch delivers observability and enables real-time notifications for exceptions. Personas. Personas play a key role in this system. And when we originally designed it, we said that we were going to have developers at the center of it, because developer experience was important to me. ECS empowers the developers to now lead the build independently, no longer needing a dedicated platform team to support them. In addition, I talked a little about this custom low-code engine that KPMG developed. This helped us with crafting business logic as functional tables, modeling the data, and then validating with our sample data, and generating Node.js JavaScript code for us. In addition, this could all be deployed using our standardized GitLab Terraform pipelines. And then lastly, all this empowerment, it gives the power back to the hands to my business stakeholders so that our accountants and our tech team now take full ownership of this system. They are responsible for the costs, the build, and the operation of this system. As I mentioned before, every month during crucial times of the accounting close, we process hundreds of millions of events. ECS provides that on-demand, high-performance, and scalable Fargate. When running our engine, we initiate 128 Fargate tasks, which collectively spin up 900 Node.js workers for parallel processing. Our database is divided into 128 hash partitions. Each Fargate task operates within its own separated section without any database contention. To initiate this process, event triggers a Lambda function, and it's a two-step process, which first populates SQS to start up Lambdas across our 128 database partitions. Secondly, the Lambda function then starts our Fargate tasks. And here's where it gets really cool. Once processing is complete, the containers shut down automatically, reducing costs as the system operates only during specific times of the month. So what's the big payoff in all of this? We saw ECS and Fargate enable our accounting system to scale up to handling hundreds of millions of events, improving our processing speed by 65%, and scaling down to reduce our cost by over a third. And we're not even done. We can actually do a lot better than that. We also saw that ECS and Fargate support a responsive, event-driven architecture with seamless integration to adjacent AWS services. And this is my favorite part because this is the thing that Fannie Mae is very, very sensitive about, back to the scope of what we do from a mission-critical perspective. We have comprehensive security measures. Built-in guardrails and security policies through ECS and Fargate are reinforced by and enforced by our Cloud Center of Excellence. This is further supported by our low-code engine that we built for efficient management and governance of our functional logic. More to the security, so we have advanced identity and access management. Utilizing IAM, we ensure least privilege across granting users and services only the permissions necessary for their tasks. This significantly significantly minimizes security risks and potential misuse. I do want to cover some business outcomes here. The new loan accounting system extends its benefits to the business as well. A 65% reduction in processing time is a critical enabler of continuous accounting, allowing real-time processing of financial transactions to ensure that data is always current and readily available. The faster we can go from actuals to forecasting, the better everyone is at the end of the day. AWS ECS, other services, and our low-code engine enable us to make changes quickly and adapt to the evolving needs of our business stakeholders. And this is the cool part. Data is now available to all the business more quickly with increased accuracy and accessibility. Back to that whole forecasting thing I was talking about. Before I hand this back to Ollie and Jen, they talked quite a bit about the abstraction spectrum. And Fannie Mae is just one example of how we used template as a service effectively. Before I hand it over, I do want to say one thing. I talked quite a bit about this importance of developer experience in DevJoy. If I can offer you one pro tip, it's this. There are the tools that everyone talks about and the ones no one uses. If your developers aren't making noise, that is a sign. Thank you. Back to you, Ollie.
Awesome. Well, Thank you very much, Michael. That was an awesome case study, hearing around how Fannie Mae are using ECS for their event-driven workloads. And what was that, 65% reduction in processing, 33% cost savings, real powerful business metrics in using serverless containers. So thank you very much. Thank you very much for attending this session. We've provided all of the additional resources, including a copy of the slides, links to some of the Backstage plugins, links to Harmonics, all on that landing page. So feel free to scan the QR code and you get access to all of that.